All right. So at this moment, I'll pause. Is there anything that you'd like me to explain better, or is there anything that you're not clear on? No? So we're good? All right. No problem. All right. Good to know. So we're good, man. All right. We have progress. I mean, this is the basics, so it's supposed to be good. Yeah? All right. So we're now going to take it up a little bit. So I'm going to make it a little bit harder. Ready? What if I asked you, what is the integral? And this is going to be our last basic one. What is the integral of x plus 1 all squared times 1 minus 1 over x dx? Now, here's the thing. I know your mind probably going, all right. So Suarez probably tell me so we can use what's the name? Um integration by parts, or we can do substitution, or we can try something else. That's literally what integration is. Like you have to figure out which method you can use. But what I'll say is, when you have something like a square here, and it's multiplied by another expression, what you can probably try is to expand and simplify. That's always one of the easiest methods to try. Ready? So let's expand this, right? So when I talk about x plus 1 all squared, right, means x plus 1 times itself. And if you remember this from when you were in high school, you could expand it by saying x times x and yada, 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 that kind of stuff there. But I'm not going to go through the long way of it. I know the answer is going to be x squared plus 2x plus 1. So I'm just going to substitute that in. Ready? So I know that this is now going to give me x squared plus 2x plus 1. So that's what I have for x plus 1 all squared, right? Cool. And then I'm going to multiply that now by 1 minus 1 over x. Now, if I were supposed to change it, let me not write that over there. So if I were supposed to change 1 minus 1 over x to one fraction, this is 1 over 1. The LCMs are x. So 1 into x, let me put it below it. Probably remember it better that way. 1 over 1. The LCM, more than likely, when you're finding the LCM of algebraic fractions, you just multiply the denominators. So 1 times x is x. More than likely, not always. So 1 into x goes x times, so this will give me 1 times x, which is x. X into x goes 1 times, so 1 times 1 gives me 1, so this is x minus 1 over x. Now I did that because doing that would allow us to make it a much simpler fraction to work with, right? You didn't even have to do it if you didn't want to, but it would make your life easier, all right? So I'm going to have now x minus 1 over x dx. Again, you don't have to, you could just expand as you wanted, but I decided to do that. Ready? Now, this over x here is going to be all in the denominator. I'm not going to trouble that, none at all, right? Now let's expand the numerator. So let me change the ink here so you guys can follow. Ready? So when I say x times x squared times x, then I'm going to say x squared times minus 1. I'm going to do this for each of them. Ready? So when I simplify this now, x squared times x is going to give me x cubed. Then x squared times a minus 1 is going to give me a minus x squared. So that's the first one. Then where you're going to do now, you're going to go again and you go to the second one. So I'm going to have 2x here now times a minus 1 over here. When we work that out, we get that it's 2x times x, so that gives me now a plus 2x squared. Then I get 2x times a negative 1, I get a minus 2x there. All right. Then let's do the last one here, which is 1 times x, and then I have 1 times minus 1. And what we get when we do that now is going to be plus x minus 1, right? Now all we have to do is simplify it. Ready? So let's simplify. So here, there's nothing to cancel with the x cubed, so I just get x cubed only. So I have that there. Now I have minus x squared plus 2x squared. When I simplify that, that gives me just a plus x squared, because you have 2001, you have 1 at the end of the day. Minus 2x plus x, that gives me a minus x, right? And then I have a minus 1, all divided by x dx. Now, remember that example that we had before, when we had something like this up top? You guys see this example here, guys? You see this? Now look at the familiarity with what we have here. It's almost the exact same thing, right? So what we're going to do, we're going to apply the same rules. Ready? So we're going to divide it again. Cool. So when I divide x cubed by x, that gives me x squared. So divide x cubed by x again, that gives me x squared, guys. X squared by x, that just gives me x. X divided by x gives me a -1, and then I'll have a -1 over x. And we're going to be integrating each of these. So simply now, let's get the integral done. When I integrate this, I'm going to get x cubed over 3 raised to the power by 1 divided by the new power. And I get x squared over 2, and I get a minus x here. Or then I get minus x whenever you're integrating a constant, the constant value times the variable. Then here it is 1 over x. So you know when you integrate that, it is ln mod x. And I beg you, don't leave off the mod x, because if you leave it off, you leave off your mark. All right. So this is the answer to the third one. Now again, it wouldn't be so straightforward. You have to try and figure out what methods would apply. Easiest thing I can say is if the power is low, then the possibility exists that you can actually use some kind of algebraic manipulation to simplify it. All right, so that is a basics to integration. Cool. So those demonstrated how you use the integral rules, nothing too heavy, nothing too hard. But what we're now going to do, remember I mentioned integral curves up top? So we're going to look at how we actually evaluate or say how we actually explore integral curves. So remember, an integral curve is the curve you get when you do an indefinite integral, right? Now what we want to do is we want to find the exact equation of that integral curve. So what we're going to do, once you have the gradient function, which is the differential, right? And once you have a point that the curve passes through, then you're very much on your way. So for example here, we're going to start with a simple example. We're going to say that given dy by dx is equal to 2 over x plus 1 and passes through the point 1, 2, what you want it to do is find the equation of the integral curve. Ready? So what we're going to do, let me change the ink here. Ready? Ready. So for the solution now, what we're going to do, we're going to start with the gradient function here, which is dy by dx. Ready? So dy by dx is equal to 2 over x plus 1. Now, what we're going to do, I normally tell my students to refrain from doing this, but meds dy by dx as a fraction in a sense, even though it's an x, also break it into a fraction. Ready? What I'm going to do, I'm going to cross multiply, so I'm going to have dy. I want to get the x's with respect to x. So dy is equal to 2 over x plus 1 times dx. Ready? Now, once that is the case, I can now say integrate both sides. So remember, when you integrate, you're going to get an integral curve. So I'm going to integrate both sides now, right? When I integrate now, I'm going to get the integral of dy is equal to the integral of 2 over x plus 1 times dx. I don't want to go down too far, so I'm just going to come up top here now. Ready? Now, some of you probably be wondering, how am I going to integrate dy? There's nothing there to integrate. Now, meds, there's actually a 1 here, but in mathematics, when there's a coefficient of 1, we don't normally write it. So if I integrate 1 now, it's just going to give me 1. Why? Now, I'm integrating with respect to y, and it's an indefinite integral. So I'm going to have my constant here, which we call the constant of integration. So I'm writing this now, but you don't have to. But I'll demonstrate why you don't have to write it. Ready? Now, when I integrate over here now, the integral of 2 over x is going to give me 2 ln mod x. How did I get that? Let me just demonstrate up top. Integral of 2 over x, you can just write it as 2 times the integral of 1 over x. And therefore, integral of 1 over x is ln mod x. So that's how I got that there. All right, so in case you didn't see it. Then I'm going to have the integral of 1. That's just going to be x. Then I'm going to have my constant of integration for x here. So here's the thing. I want to solve for y. Ready? So when I carry the c1 over to the next side, it's going to be 2 ln mod of x plus x plus c2 minus c1. Here's the thing. We have two constants. We have one c2, which is a constant, and we have c1, which is a constant. When you subtract two constants, you just get another constant. So more than likely, when your teacher was demonstrating this concept, he literally just wrote the c over here alone, which is perfectly fine. But I did it to demonstrate how you just get the c at the end of the day. So it is 2 ln mod of x plus an overall c. You don't have to write c2, c1. You can just write the c on the x side, that's it. But I wanted to demonstrate how you ended up at this overall c here. The difference between two constants is another constant. It doesn't really matter. All right? But guess what? This currently is an integral curve. We want to know what is the actual equation of this integral curve. So what we're going to do, we're going to use the information given. We know that the curve passes through 1, 2. And remember that when you have coordinates, so we know 1, 2 is on the curve. So all we need to do now is substitute values. Ready? So remember, when you have a coordinate, the first value is x and the second value is y, right? So what I'm going to do, I'm going to substitute these into the above integral curve. When I do that, I get that 2 is equal to, so 2 is equal to 2 ln mod of 1, right? Cool. Plus 1 plus c. Now, you don't have to worry about the mod here. If you remember your econ 1003, mod just means you get a positive value, right? So 1 is already positive, so you don't have to worry about that. So it's just ln of 1 in this case here, right? Now, if you also remember your econ 1003, ln 1 is just 0. So this is 2 times 0 plus 1 is equal to c. When I solve for c now, guys, ready? It's going to tell me that 2 is equal to, let's see here. 2 is equal to 1 plus c. Solve for c, 2 minus 1 equals c. This tells me that c is equal to 1. So the actual equation of the integral curve, therefore, what we're going to say now, y is equal to, so from this equation that we had up here, we now find what the value of c is. So we know the actual integral curve. Because remember, I was demonstrating to you earlier that with the integral curves, it depends on the value of c. Once we have that value of c, then we know what the actual curve is. So the actual curve now is y is equal to 2 ln mod x plus x, and then we know the value of c to be plus 1, and that's how you get that done. All right, so before I move on to the next integral curve example, is there anything that you'd like me to clarify from this example here? Anything you'd like me to clarify?